Right, 8.9, improper integrals. That means we'll be dealing with infinities. All right, infinities. So what do we do if we have an integral that goes from 1 to infinity of 1 over x squared? Well, let me draw it up real quick. I'm only going to draw the right-hand side of this. Ah, shoot, I'll draw the left-hand side too. But we're going from 1. We want to get all of this area here. But infinity is not a number. We can't plug in infinity. Now here comes these 3 letters that I know makes every student groan. L-I-M, the limit. So what we're going to do is we're going to pretend like there's some b here. And we're going to say that we're going to b. But there's a little bit more to this. That limit is coming up. We now have to say we want the integral of 1 to b of 1 over x squared dx is the limit as b goes to infinity. And we have to set them up this way. And we'll do this problem in a second, but here's our definitions. This is kind of the deal where we have right now. We have something from a number up to infinity. So we're going to call it some b, and we're going to let the b go towards infinity. Now, of course, we could do it the opposite direction too. Maybe we're going from negative infinity to some b. That means we're going to call it some sort of a, and we'll let the limit as a goes towards infinity. And of course, it could happen on both sides, where we have a negative infinity to infinity, but we're going to have to break this up into 2 pieces. The limit as a tends towards negative infinity up to some point c. We choose a value, a convenient, simple value that we could choose. And then we're going to go from that c up to some b. But we'll let that b tend towards infinity. I know it seems like a lot. Now, if you get a number, we're going to say that they converge. You actually get a number. Otherwise, they diverge. That means you get that it blows up to infinity, because infinity is not a number, it's a concept. So we'd say that it diverges. So let's see this problem in action. There's nothing to it. So we'll say, okay, well, let's rewrite this. Limit as b tends towards infinity from 1 to b of x to the negative second power. Sorry, I'm going left to right, but I don't have room. So we have the limit as b tends towards infinity, and now let's tackle our problem. Oops. Let's just write it. So we're going to add 1 to the exponent, which becomes 1 over x. X to the negative first, and we need to make sure to use a negative. Now we're going to evaluate from 1 to b. So now we have the limit as b tends towards infinity of negative 1 over b minus negative 1 over 1. And as we all know, if the denominator grows without bound and there's a constant up top, it just goes to 0. So we're left with negative 1 times negative 1, which is equal to 1. There's the area under the curve from 1 to infinity. Hey, there's our first improper integral. Well, let's try one more. Let's say now we're going to go from negative infinity to infinity of 1 over 1 plus x squared dx. Well, that's the antiderivative, or that's the derivative of inverse tangent. So we know we're going to be able to plug those in, but we're going to need to change things. So 1 plus x squared looks a little something like that. They should be symmetric, so we're trying to find all that area. I'm thinking a good way to break this would be at a, 0, and some b. So let's set it up. Let's go from negative infinity to 0 of 1 over 1 plus x squared. I'm going to come back. You can erase 2. I'm just writing it out this way. And then we're going to go from 0 to infinity. I'll give yourself a little bit more room there, dum-dum. 0 to infinity of 1 over 1 plus x squared dx. All right, broken into two pieces using those rules of integration. But now let's just make life easier and let's set it up. We're going to say that this is going to be our a. So we'll say, oh, let's let this go to a, and we'll say, let's take the limit as a goes to negative infinity. Now we'll do the same process on the other side. We're going to call this b, and we're going to take the limit as b tends towards positive infinity. Okay. Let's get it. These aren't so bad. But it's all about how you set them up. And your teacher will be a jerk. You plug in infinity? No, you lose all your points. You can't do that. This is inverse tangent of a to 0 plus the limit as b tends towards positive infinity of inverse tangent of x from 0 to b. So what do we have? Looks like we have, oops, the limit is a tends towards negative infinity of inverse tangent of 0 minus inverse tangent of a. Plus, we have the limit as b tends towards infinity of inverse tangent of b minus inverse tangent of 0. Fortunately, inverse tangent of 0 is just 0. Good thing we didn't choose something like 4. We wanted to choose something simple. So we have, this is just 0. That's just 0. So we have the limit is a tends towards negative infinity of inverse tangent of a plus, oh, nope, that's a minus. Did I forget my sign? Oh, dude, that's a minus. Sorry about that. Gosh, I must improve. The limit is b tends towards infinity of inverse tangent of b. And we all know these values. You took Calc 1, didn't you? So this is going to go to negative pi over 2. Limit is a tends towards negative infinity of inverse tangent of a is going to be negative pi over 2, but we have a negative in front of it. And then our next one, the limit is b tends towards inverse tangent, the limit is b tends towards infinity of inverse tangent of b just goes to positive pi over 2. And it looks like we just get pi. There are the beginnings of improper integrals. We're also going to have some other types as well. But yeah, there's a good beginning. There's a good beginning. So hopefully you got these concepts that you cannot plug in infinities. You take the limit and you just call it a letter, A or B. If it's on the left, call it A. If it's on the right, call it B. Keep it straightforward. Keep it the same way each and every time, and we should be good. All right. I'll see you in the next video.